to be here. Good to see so many Cloudera people here. Hey, there's Ben. Hey, Ben, how you doing? They are just as excited as you are to find out what it is I do for a living, since they have no idea. Roughly, Cloudera people, right? I thought that was going to be funnier. Anyway. All right. Talking a little bit about building Yarn applications today. So a little bit about me first. If I was to die today, this will be what is written on my tombstone. This is my fundamental contribution to humanity. It's 139 characters, giving a definition of what it is to be a data scientist. I am a data scientist. I am a competent software engineer and a competent statistician. I'm not particularly good at either one of those things, but I'm passable at each of them. And I coined this sort of clever definition for what it is I do. I'm Cloudera's Director of Data Science, which mostly means that I go around and talk to lots of people about Hadoop and Hadoop-related applications and help them solve problems on Hadoop. And I also do some of the stuff I'm talking about today, which is building tools and building frameworks to make it easier to do things on top of Hadoop. All right? So let's get started with kind of a state of the world. What can I do with Hadoop right now? What can I do with Hadoop on Hadoop 1.0.3 or CDH3 or whatever you have going on these days, right? So there's a couple of options I have, really two primary options. So I can obviously run MapReduce jobs, right, which are obviously fantastic. And I can also use frameworks like Giraffe and Hammer to do a different programming model, which is called bulk synchronous parallel processing, just slightly more generic. Now, Giraffe, more so than Hammer, is really like very much a hack on top of MapReduce. It's really, if you actually look at the code, it's running a map-only MapReduce job and then doing some sneaky stuff behind the scenes to actually create a bulk synchronous parallel model. The kind of canonical example of things you would do with MapReduce, you would use that to count words. Obviously, Hadoop is a giant distributed system for counting words. And BSP, you would calculate PageRank. It's sort of graph-oriented processing models, okay? So this is pretty cool. Like, this is a good sort of set of things that you're able to do. A lot of what I do, though, is I go around to academic conferences, machine learning conferences that are not really so much industry people, but academic people. And I'm actually just going to rant for a second, because I've been doing this for like 6 months now, and I have a lot of bitterness built up, and I'm going to take it out on them right now. So I go to these things, I go to these machine learning conferences for 3 reasons. One, I go to recruit people, or as I like to think of it, rescue. I go to rescue people, save them from graduate school. 2, at least in the conferences in the Bay Area, and then like say Boston and Europe, the coffee and pastries are just out of this world. Like if you ever get a chance to go, there's like some academic bakery or something somewhere. They just make just delicious stuff. And the 3rd reason I go is that like roughly 1 out of every 10 talks will be interesting and useful to me in some way, right? The other 9 talks will be about how much they hate Hadoop and how MapReduce is bad at everything and how they really should use their other framework instead of Hadoop, instead of MapReduce, right? And this is really sad. So anyway, look, there's no shortage of other frameworks. Parallel processing, not new, right? We have OpenMPI, there's Grid Engine, there's Moab, there's Torque. There's all this great stuff you can use to do big distributed parallel processing, right? Nothing new here. But what we have now, in addition to sort of this an ecosystem, is Yarn. So Yarn is at the core of Hadoop 2.0. It is Hadoop's new resource scheduling system. If you guys are familiar with Hadoop, you know the kind of the Hadoop 1.0 bottleneck was the job tracker, was the thing that keeps track of MapReduce jobs. What Hadoop 2.0 does is it basically moves MapReduce into a client library. It moves it out of sort of the core of Hadoop, so you can actually scale a Hadoop cluster. I think before the upper limit was something like 4,000 nodes, and with this new architecture it'll scale up to like 10,000 nodes. And the real virtue, though, of moving MapReduce into userland is that we can now run all kinds of other stuff on a Hadoop cluster. So I feel like this is kind of a secret right now. And I want to get the secret out there, because like Cloudera, all of us, really, we are motivated for this not to be a secret. And the secret is Hadoop 1, it's over. Whatever your academic framework is, stop working on it. Time to start working on stuff on Hadoop. Okay? Hadoop has secretly, cleverly leveraged the explosion in data to put a parallel computing system, an operating system effectively, an operating system in the sense of it runs applications, that's what it does, in every single one of the global 2,000 companies by the end of 2013, right? That's basically going to happen. This is the enterprise software equivalent of having a desktop on every, like having a Windows PC on every desktop back in the 80s. You now have a platform everywhere, where your applications can run. And there are companies like Cloudera, like Hortonworks, like MapR, like IBM, that will support it. You don't have to support it yourself. This is fantastic news. You guys are all like, yeah, obviously we know this. So this is mostly like for the people on video who maybe didn't know that, right? But this is very, very exciting. This is a really big deal. All right. So maybe you say, yeah, Josh, that's fine, but I mean, who really needs parallel processing, right? Web companies, they need big, large-scale machine learning stuff, right? Oil companies, big, complex simulations of reservoirs. How big is this market? I'm actually going to claim just about everybody needs parallel processing. And I know this because I go all over the country. This is a blog post I wrote a couple of months ago on constructing case control studies. This is for a healthcare company in the Midwest. They had this problem essentially constructing these case control studies where this whole system was taking them like 5 days to run. So we moved it over to BSP on Giraffe, and now the whole thing runs in like an hour, right? This isn't, big, super sophisticated company. They run into these problems too. And as the data sets get bigger and the value as people start getting the low-hanging fruit out of their data, this stuff's going to get much more competitive. And everybody is going to be running machine learning algorithms. Everybody is going to be running large-scale simulations. Everybody is going to be solving very large-scale optimization problems. Again, everyone's like, yes, Josh, we know that. Please move on. Okay, that's fine. Not a problem. So I want to talk a little bit about what it was like. I built a new processing framework on top of Yarn called BranchReduce. And if you guys have seen my talks before, I'm not a huge fan of like Encyclopedia PowerPointia. You know what I mean? Like just big, like you guys can read, right? If you read the slides, that'd be fine. So I sort of want to tell the story of how this stuff came about and sort of explain motivations and stuff like that before we get into the actual framework. Depending on your perspective, that may be uninteresting or interesting, but I'm going to do it anyway. All right. I thought of this morning as I was writing this presentation. Terrifyingly accurate paraphrasing of JWZ, of Jamie, right? Some people, when confronted with a tedious problem, think, I know, I'll write a framework. And now they have two tedious problems. They have the framework and they have the original problem, right? And the problematic part, like the really terrifying part of the statement, is that this is actually, like, tedious problems are recursive, right? So once you've written this framework and you have these two tedious problems, you say to yourself, well, I have more tedious problems. Obviously, I should solve them with yet another framework. So fortunately, unfortunately, I'm not introducing one framework today. I'm introducing two. Sorry about that. It just kind of happened. Another thing, I'm in love with this book right now. I highly recommend picking it up. It's by a guy named Austin Kleon, and it's called Steal Like an Artist. I'm pretty sure that's how you pronounce his name. I'm probably going to butcher a lot of last names today, and I apologize for that. People call me Josh Willis all the time, so I don't feel so bad about doing it. The idea of this book is that everybody steals from everybody else. Everything is a remix, right? Nothing I'm talking about today is particularly new or innovative, aside from the fact that I did it in this new context. And I'd like to, as I go through, give credit and like admiration and love to the people who inspired me to create these things. Again, being a data scientist, I'm not a genius software engineer. I copy people who are genius software engineers, and I kind of do stuff they do, and I adapt it in new contexts. I worked at Google for a long time, and I had this theory that like Google's code base is exceptionally good. It's not perfect, but it's exceptionally good. And I have this theory that all the code at Google was like Jeff Dean wrote some code, and then like someone else copied it and modified it slightly, and then like someone else copied it and modified it slightly. That's sort of like, that's my theory of how Google's code base evolved to be so high quality. And then like ideally Jeff would come along later and like fix it, but yeah, I don't know. May or may not have happened. Nonetheless. Okay, so you're getting started with Yarn. There's another talk later. If you're really interested in the guts of how Yarn works, there's another talk later today about that, written by people who know it more, certainly better than I do. The example application ships with CDH4, ships with Hadoop 2.0. It's called distributed shell, and it is exactly what it sounds like. I'm going to start up a master, I will start up a bunch of nodes running containers. Each of those containers will execute a shell script or some command on the shell, something like that, right? And this ships, you can like go read this code and look through it and see all the stuff it does. It's 1,600 lines of Java code to run a shell command. It's a shell command, and it's 1,600 lines. I mean, I expect like at least an audible gasp of horror, right? This is not good, right? This code does really, I mean, it does two things, okay? It does a bunch of RPCs to set things up, like talk to the resource manager, get resources, right? Fire off an application. And it does configuration. It's essentially just a bunch of protocol buffers with configurations. Configuration, RPCs. That's basically it, right? So I'm looking at this thing. So I'm like thinking, okay, Yarn, awesome. Cambrian explosion. Time to get cranking on this stuff. I want to build a Yarn application. This is the reference point I look to. I see these 1,600 lines of code, and it's like, this is not going to work. We're going to have to do something else. All right. Trying to think how best to sell this. Yeah. Writing complex MapReduce pipelines is not trivial, right? And it's not trivial for normal people. And Yahoo and Facebook, when they were adopting Hadoop back in the day, knew this, realized this, and they each came up with different solutions for handling this problem. Yahoo obviously came up with Pig. Facebook obviously came up with Hive. They have different execution engines. They've been kind of constantly competing with each other to see who's better in different use cases, all this kind of stuff, for quite some time now. And I'm trying to kind of nip this in the bud. I'm trying to urge people not to do this again. Please, 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 do not write a programming language for writing Yarn applications. Silk or anything else. If anyone from Intel is here, please don't do that. Please. Please, 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 do not do that, right? Let's do this once. Let's do it right. And most importantly, let's leverage all the great stuff we already have, right? We have a ton of great stuff out there. We have Thrift. We have protocol buffers. We have Avro. The RPC, distributed system, evolving system problem, pretty much solved. In fact, it's been solved 3 times, as a matter of fact, at least. I'm sure there's some I'm missing, right? But the important thing is there's lots and lots of applications out there that are already written in Thrift and are already written, right? And what we really want to do is make it super easy for people to port their existing applications so that they run on Yarn. That's really like the best possible thing for us, okay? Does everyone see why that's the best possible thing for us, right? Big install base, move it over. This is good, generally. Okay, listen, you're not nodding, so listen, it's the best thing. There, done. Trust me, I'm a data scientist. All right, so this is the framework I wrote. It's called Kitten. So I was playing with Yarn. Yeah. Big data and kittens. I can't wait for the pictures. All right. Couple of things. All right, so when you're writing a Yarn application, Yarn is designed very much with MapReduce in mind, sort of MapReduce first and foremost. When you're writing a Yarn application, the first thing you're doing from the client is kicking off an application master. And that application master then goes back to the resource manager, the scheduler, and it gets a whole bunch more resources, right? This is a core idea. So most of the time, though, if you're running kind of an interesting application, there's some kind of master that's keeping track of everything, right? Master worker programs, BSP programs, MapReduce programs, they all have something like a master, okay? And I had a question as I was designing this, well, do I want my application master, my thing handling my resources, to be the same as my business logic master? Should these two things live in the same binary, effectively speaking, right? Because I could kind of make a case for no. I might want to write a C++ application. And insofar as Yarn is very Java-focused right now, that would be kind of painful, right? So maybe I want to like say, I'll start an application master, and I'll decide that one of my containers is the business logic master, and then all the other containers are like slaves, or different kinds of slaves. Does that make sense? All right. Turns out to be kind of painful to do that. And the main reason, at least for me, being a not very good programmer, is dealing with ports. Is knowing I start up a master, it has to be listening on some port, right? And it has to be able to communicate that port to all the slave nodes so they can all go talk to the master and register with it, all right? So the easiest way to do that is to have the whole thing living in the same binary. So when I start the master, I can figure out what hostname I'm on and what port I'm using, for my application logic. And then when I go to start all the nodes, I want to pass that information along to them so they know how to talk back to me. Very common problem, right? Okay. I should say, I'm sorry, the other thing. Like, the model here is we really want to be able to, as much as possible, develop all of our applications locally using Thrift or protocol buffers or Avro without really having to give any thought to Yarn whatsoever until like the very last minute when we're ready to deploy, okay? So this is kind of structurally the problem. And structurally the solution is a couple of services I wrote. So most of Yarn lifecycle management is pretty boring. If you guys are familiar with the service pattern in Guava, Guava is Google's Java sort of useful stuff library. Services are used actually throughout the Yarn system itself. And the idea of a service is very simple. You have something that does startup, something that runs for a while, and then it stops. It starts, it runs for a while, it stops. But it turns out to be actually kind of interesting when you can do sort of state transitions between those different phases to actually like handle the logic well, right? So that's essentially what Guava does for you. So we have a Yarn client service, which starts up, registers an application, keeps an eye on it, and then when the application says I'm done, shuts everything down cleanly. And similarly in the application master, we have something that starts up, registers itself with the resource manager, fulfills your request for nodes, keeps an eye on those nodes, and then shuts everything down when you're finished running. Very simple idea, and very much encapsulated in a couple of Java classes, right? Create the service object, start it, off you go, run your business logic. When you're finished, stop it. That's it. Easy peasy, like a lemon squeezy, as the guy who took me up Machu Picchu used to say. Don't know why I thought of that just now. All right. Services are good. All the sort of RPC logic we've now encapsulated inside the service library. We don't have to think about it anymore. This is a good thing. If you remember the 1,600 lines of code, a lot of RPC stuff, also a lot of configuration stuff. We spend a lot of our time essentially doing configuration inside of Java. So Java is not a great configuration language. I think we would all kind of agree with that. Not a great configuration language. There actually are fantastic configuration languages. I went out and researched some of them. And it turns out that far and away my favorite was Lua, which if you've ever written a sort of extension to World of Warcraft, you probably know really, really well. It's a fantastic configuration language that is pretty widely used in the gaming community for doing all kinds of like for configuring levels and that kind of stuff. It's very popular among 18-year-old boys, that sort of thing. These are the kind of people we need to recruit, guys. Like, I'm not kidding. We need to like use this as a lure. Come, write Lua. Your World of Warcraft skills finally pay off. Anyway. Okay. Thought I got that one. Yeah, so Lua is actually kind of fantastic as a configuration language. I really, really like it, right? It was a little bit of a warm-up period, but it's very small. The jar for Lua J, which is the Java implementation of Lua, is only like 240 kilobytes. Tiny, itty-bitty small, right? Jython is like 2.2 megabytes, I think. Closure is like 1.4, 1.5, something like that, depending on what version you're using. So it's super tiny. It's also incredibly, incredibly fast. I'm now trying to read what I wrote up there. Oh yeah, it's a programming language, but not much of one, I guess would be the way I would say it. It's primarily a configuration-oriented language. I'm going to show an example of it in a second if you're not familiar with it. But functions are there when you need them, for the occasions when they are useful. Most importantly, it supports inheritance really nicely. I can have references in my configuration to different values. A very common problem when writing these kinds of applications is having to share information or replicate information from the master out to the nodes. Does that make sense? Right? We want to have these things have to know the same sort of stuff, right? So by using Lua and using this inheritance mechanism, you don't have to repeat yourself quite so much, which is a big virtue. Like again, of those 1,600 lines, a lot of it is just fairly repetitive. Like copy this file here, and then 200 lines later, copy the file someplace else, that kind of thing, right? It's also very forgiving of undefined values, which is nice. So what we can do is when I'm specifying the configuration for a container node for one of the slaves it's going to run, I can include references to variables that I haven't defined yet. For example, what the name of the master's host name and what the master's port are going to be. And Lua doesn't care. It'll keep working anyway. Then on the master, when I reload that configuration information with those values defined, I can then execute that code and actually get the value I want out of it. This made me just deliriously happy. All right. Other virtue, it integrates really well. It's a good little slave language to Java and to C++. And I would really, especially for my machine learning friends, I would really like to see C++ applications running on Yarn at some point in the very near future. So having the whole configuration done in Lua means that I don't have to care whether my application master is written in Java or C++. Okay. So Kitten comes with 2 utilities. I actually wrote 3, but 2 that we're going to talk about today. First Kitten utility is called cat. This is a kind of, so the idea here is I have so Lua doesn't have hash maps or arrays, it just has tables. This is a Lua table. So there's a base table up there which defines a couple of values. And then with the derived table, what I'm doing is I'm taking in a reference to that table, and I'm creating a function. So that cat function actually returns another function. And what that function does is it takes in a table and just copies the values from the original kind of underlying base table into the argument you passed in. So this is a really nice, easy way to do configuration inheritance, right? I can specify a common set of values in a table someplace, and then in the master in the node, I can reference those values, but also modify or override them if it makes sense. All right. Second Kitten utility is called Yarn. And Yarn is really just a sort of checker function. It goes through and it basically validates that your configuration does everything that it needs to do, that all the parameters that are expected are set, all that kind of good stuff. It's really just an error checking function. And it takes in a table. This is distributed shell. This is distributed shell. You don't have to write any code to run distributed shell under Kitten. It's just configuration. That's it, right? I'm skipping a little bit of like setup stuff, but the whole file is like 40 lines of Lua. 1,600 lines of Java, 40 lines of Lua. Seems like a pretty easy decision to me. Okay. Thought I hit it, but the next slide didn't come up. There we go. All right. So we have this framework. We have this nice, easy way of writing Yarn applications, at least Yarn applications that do relatively simple things. Start up, run for a while, shut down. What do we do with it? So my background, I went to grad school in operations research. You guys know operations research. Mathematical programming optimization. Yes, some fans out there. I was like, operations research. Yeah, we're party animals. Anyway, I don't really get to use it so much in my, it's a weird thing. I don't really use it so much in my day-to-day life. I don't work at an airline or a logistics company or a finance company, but I miss it. I really do. And I like branch and bound a lot as a distributed computing problem, because as you're kind of going down the stack from MapReduce as being incredibly simple, BSP being slightly less simple, branch and bound is actually the next thing you want most of the time. It is a master worker paradigm with a global shared asynchronous state. That's essentially what branch and bound is when you implement it in a distributed system, okay? If you're not familiar with branch and bound, the way it works is I have some problem. I have some optimization problem. It's a traveling salesman problem. It's an integer programming problem. It's a Steiner tree, something like that, something I'm trying to optimize, okay? And there's a bunch of constraints. So what I do is I essentially partition the search space by imposing extra constraints on the problem. And then I effectively simplify the problem down. So I'll say, for instance, this variable has to be 0, or this variable has to be non-zero. And then I solve the smaller problem that results from that constraint, okay? If that smaller problem comes up with a valid solution, then that becomes I should clarify, let's say minimization, just for the sake of argument. I'm doing a minimization problem. If I come up with a valid solution, that valid solution is now an upper bound for my problem, okay? If I don't come up with a valid solution, I want to come up with something like a lower bound. Something that's like, okay, the minimization could possibly be this low. I don't know where exactly it's going to be, but it might be this low. And the idea of the bounding is that when I come across a place where the lower bound is greater than my global upper bound, I know to bound that tree. I can stop exploring because there's no possible way any lower node in that tree could be any better than a solution I've already found, okay? That's roughly the core idea. So when you're doing this in a distributed fashion, the idea is you're taking all these nodes, which represent tasks, spreading them out across the cluster, and then you have this shared state, which is the current best solution and its value, that you're then kind of passing around to everybody. And as different nodes come across better solutions, they update that state, and that gets asynchronously propagated elsewhere. Okay? So, core challenge of this is that the trees tend to get pretty unbalanced pretty quickly. What will happen is you're going down a branch and bound tree, you're working on some section of the tree, and it gets bounded right away, right? You find a better solution at some other part, so very quickly bounded. So unless you're careful about how you distribute the work across the nodes, it's very easy to fall back into an effectively, single-threaded approach, where there's only one node that's actually doing any of the work in the system, right? So that's sort of the problem we have to get around. And the way we do that is using an algorithm called work stealing, which people have studied somewhat theoretically, but turns out to have really sort of nice practical properties. The idea is simply that when a node runs out of work to do, it goes to the master and says, hey master, I'm out of work, give me something to do. And at least in sort of the BranchReduce implementation, the master will then check its sort of cache of tasks to do, and if it has any, it'll send it back. If it doesn't have any, it'll go out to the other nodes and try to steal tasks from them. So it'll go to that node and say, hey, do you have any work? Do you have any work? And if it does, those nodes will pass those tasks along, and the master will then reapportion those tasks to the nodes that don't have any work to do. That's the core idea. And that's basically how we kind of maintain good performance, even in the face of this sort of unbounded, or sorry, what's the right word for it? Unbalanced, that's the word, unbalanced search space. Okay. All right. So BranchReduce. BranchReduce is stolen, I should say, I guess I didn't say it before and I wanted to, and I feel bad. Kitten is a riff on a system at Google called Borg config. Borg is Google's internal system for managing like data centers and computers and that sort of stuff. Borg config is a configuration language, internal to Google, for configuring those services. And it was kind of what I had in mind when I was writing Kitten. That was very much what I was going for, right? Those guys did a really fantastic job. I don't know that I fully appreciated it when I was there, but being out on the outside and looking at those 1,600 lines of Java, I really was very grateful for having it. So that was who I wanted to pay homage to. On BranchReduce, I stole from 3 people. In a sort of inspirational sense. I didn't actually like go, break into their computers or anything. One is a project called Jicos at UC Santa Cruz that has been sort of archived for about 5 years now. But 5 years ago did a pretty cool branch and bound implementation on top of Java. The second people I got ideas from were Mihai Budiu, I can't do it, B-U-D-I-U. Yeah, anyway. Guy at Microsoft Research worked on Dryad. He wrote a paper called Dryad Opt, which is actually a very clever way of solving BranchReduce or solving like branch and bound problems in a MapReduce context. It's actually like very clever when you read it and think through how he did it. And then finally, I think it's fair to say that I borrowed some ideas from the core Hadoop APIs. And I would say that, Giraffe probably did the same thing in my experience, right? So same kind of Hadoop-ish idea with BranchReduce. You write 3 classes. You have a task class, which is just some instance of Writable. Any instance of Writable will do. You have a global state class, which is also going to implement Writable, but has to support an additional method called merge with. And the idea here is this represents the global state in the system, so you can think of it as like a minimizing double. It's a double that can be merged with another value and will always update its state to be equal to the minimal of the 2 values. It's a very simple idea, right? And then finally, a processor class, which only has to define an execute method, which takes in a task and, which should look very familiar, a BranchReduce context, and it can then call emit on the BranchReduce context to write out additional tasks that you have to do later, right? Very easy. Oh, and of course, initialize and clean up if you want them. They're all there, right? All the configuration is just a typical configuration object. With these 3 classes, there's a BranchReduce job class. And then along with this, there are a few different BranchReduce engines that you can submit this job to. So there's a single-threaded one, a multi-threaded one, and then a distributed one. Okay? That's the core idea. Let's see. Example of this, the knapsack problem. This is going to be a little lame because we had some technical issues with the demo. I was going to actually demo this for you guys, and I can't do that, unfortunately. Good news is I'm going to open source it, like mostly tomorrow and like early next week, so you'll be able to run the demo yourself, and then, privacy of your own home. So I apologize for that, though. All right. Knapsack problem is the sort of simple implementation I did. You guys know the knapsack problem, very common, very important NP-hard optimization problem. I have a knapsack full of things. They have different weights. They have different values. and I want to put as many valuable things into my knapsack as I can without going over the weight limit, effectively speaking, right? Pretty classic problem used in portfolio optimization, a bunch of other things. So it's a 0-1 integer programming problem. Cplex is kind of the dominant player in any kind of optimization software. They're owned by IBM now. They have this file format called LP. And I wrote a simplified LP format. So this is essentially the input to a BranchReduce job using my processor. Maximize a bunch of variables. It's simplified because essentially it assumes that all the variables are 0 or 1. That's the simplification I made. Good idea, okay? There would have been a demo here, but there's not. That was really loud. Sorry about that. Yeah. Are there questions? Thank you. Sorry, I didn't mean to like stop kind of abruptly like that. One of those things. If there aren't questions, I can just talk more about, something. Hey there.
Hello. Do you have any figures on how your implementation compares to Cplex?
Oh wow. I wouldn't want. I like cannot hang really. So the simple implementation I did is just using an implicit enumeration algorithm. If you know what implicit enumeration is, really easy, fast way to solve 0-1 integer programming problems, but not really that good. I have not integrated an actual honest-to-God LP solver with the system yet, primarily because I have some issues with licensing around all those solvers. There's a lot of GPL stuff out there, and there's sort of the coin stuff is kind of maybe possibly acceptable. I was really more interested in writing the core framework. Essentially, selfishly, again, I'm not a great software engineer, but this is what I wanted. I wanted to make it easy to write Yarn applications, and I wanted a way to solve integer programming problems. So I figure I'll just build this thing and kind of describe very explicitly what I want, and then smart people will come along and fill in the rest for me. I'm pretty sure that's how open source works. Right? You guys, that's roughly how open source works. Is that fair? I mean, it worked with Crunch. I don't see why it wouldn't work here. Yeah.
Hi, thanks for your talk. I actually have one question. You hit up on some of the difficulties deploying Yarn applications. Mm-hmm. In your experience, what are some of the tooling that's required to do stuff as packaging software to be deployable, configuration management that Yarn needs to do to make it easier to actually use and operate?
Oh, that's a great question. Man, that's like pretty frustrating for me right now, right? So I mean, obviously with Yarn, you have the core MapReduce 8 libraries that are all deployed out in the cluster for you. But there needs to be some kind of package management solution, right? So I can just package up the binary and everything it needs, and it will cleverly copy it out to the right places. Right now, Kitten roughly handles that manually. You specify local files as sort of references in the Lua config, and it will go grab them and copy them out and sort of do poor man's package management for you. But obviously, that's not giving you versioning. It's not giving you, any of the kind of good stuff that you would want. So I don't, unfortunately, have a solution to that problem yet. It's a big one, and it's a good question. Yeah,
I mean, do you think like central state, discovery, maybe Zookeeper for service discovery or something like that's required to make it easier for that to manage?
I think it would certainly make it easier. It would certainly make it nicer, no doubt about that. Yeah. Yeah. Hey.
Do you see Kitten more as a sort of example that will show what we need in order for technologies in the ecosystem to use Yarn, or is this the sort of thing that are you going to integrate it into Crunch, and do you think that Hive and Pig and whatnot should use this in order to?
Oh, I mean, I think so. My feeling is people should generally stick on MapReduce. So I mean, a couple things, right? Well, Yarn is certainly not ready for production, right? It's ready for people like me and people like us, essentially, right, to go play with it and have some fun. It's not ready for production use in any sense. I don't think that's a tough one. I don't think Hive or Pig or Crunch should use it. They should all keep running on top of MapReduce. I think people who've already written stuff in BSPs on top of Giraffe and Hammer should keep using them and let Giraffe and Hammer worry about moving over to Yarn. So arguably, I would love to talk to the Giraffe guys. In fact, I'll probably go tackle them after their talk in an hour about collaborating on this. Because these are hard problems, and it's stupid to solve them over and over and over again. We should just do it once and have everybody share it. And that's really what this is about. Yeah. No one's competitive differentiation is based on how they set up resources on a Yarn cluster. If that's your business model, something has gone horribly, horribly wrong. Hi.
So, did you actually, can you tell us something about, whether you ran this application and, what were the characteristics of it?
Yeah.
How did it do compared to if you just ran it on one
You
box?
just ran it on one box, right? So, I mean, most definitely because of the core optimization algorithm I'm using it, like Cplex would beat its pants off. On the other hand, it's free, and Cplex costs money. So on a cost per unit time ratio, it's like basically, it's infinity, so it's essentially awesome, right? There's a time per unit cost, there we go. All right. It scales pretty linearly right now, up to about 10 nodes, and then after that it starts falling off because of the communication overhead, like within the kind of core work stealing framework. Again, that's mostly due to me not being a great programmer. The virtue of the way I implemented it, though, is that the work stealing library, which is written like the work stealing framework, which is written entirely in Thrift, is decoupled from the core BranchReduce APIs and the Solver APIs. So Solver APIs over here, core APIs in the middle, BranchReduce like implementation over here. So smarter people than me, and it's essentially all of you really at that point, can come along and do like a vastly superior job than I can. Yeah. And I mean, part of that will be like me going to Coin and trying to figure out what Coin libraries I can integrate to do most of the smart work for me, right? Yeah. Okay. Cool. One more question? Just one more. Anyone on anything, really? Seriously, guys, come on. One more? Hey. Oh, yeah, sure. Oh, that's what I love. Go do it. Yeah.
So, it's possible that there's some configurations that, it may, you talked about that the work stealing library may be the issue, but maybe it's configuration. How do you decide on a node whether how much work you're going to do yourself and how much you're going to, give to somebody else? At what point do you have so much work that it should go somewhere else?
That it really should
right?
go someplace else.
So,
yeah.
Did you build any kind of sort of those kinds of, optimization parameters in that allowed you to play around with that kind of thing?
Well, I mean, so my feeling was that the sort of communication overhead is only really worthwhile if somebody's not working. So long as everybody's working, I'm basically okay with the tasks being as long as they are, right? Now, when I go to do the work stealing, I use the n/2 trick, which is if you have work, give me half your work, which is one of those things that just kind of works well in practice and people don't totally understand why, And that basically, I keep stats, obviously, on like everybody's different, like how many tasks do you have currently? That seems to work reasonably well. Anyway, just like practical, I'm sure there's like papers on the theory of this, but anyway. Cool. Guys, if there are no more questions, I really appreciate it. Thank you all very much.